For drawing this direction field, we actually have an ordinary difference equation now, right? We have an unknown function y and y prime relating itself to its derivatives. I've kept my grid from before, and this problem is similar to the last one a little bit because of the last one was not dependent on y, it only had x's here, so we only had to worry about calculating at different x values. But this one's the opposite. This one has no dependence on x, and so we really only have to worry about what the y value is, and we can copy it over and over again in columns. All right, and the process is the exact same as before. So if we want to figure it out when y is -5, well, we have to plug in -5 into this. So we get -5 times 3 minus -5. Let me put a parenthesis. And that ends up equaling, using my notes, -40. Okay, well, I put a -40 here. And same thing, -4 times 3 minus -4. Well, that equals -28. So I put a -28 here. And then, one more time, -3 times 3 minus -3. Well, that equals -18. And so on going down the list. And so I'm not going to do that all again. I'm just going to start copying from my notes. So -18, -10 slope, -4 slope. Let's see, 0 slope, 2 slope, 2 slope, 0 slope, -4 slope, -10. All right, so let me start off in the middle then. So let's say when y is 0, the slope is 0. So I'm just going to put a flat line. When y is 1, it's +2, so something like that. When y is 2, it's +2, so something like that. Goes back to 0 at 3. And then it's -4, -10, so I can't draw those very well, but kind of like that. Then on the negative side, we have, let's see, -1 is -4, so pretty steep. And I can't really distinguish between those. I can't draw them that well, so it's just going to be a bunch of downward lines. And now because there's no dependence on x, right, it doesn't matter if x is 0 or x is 1 or x is 2 or 3 or 4, I can just copy these over. And that's exactly what I'm going to do. So, and I can't draw these very well, so I'm just going to point them pointing down. There's a flat one, there's up, flat again, and a bunch of downs. And same thing on this side. So let's see. As you can tell, this is probably a better job for a computer. All right. So I managed to draw them, at least with the right sign. And then if we want, we can draw integral curves. And those ones actually end up being nice. So if we start, let's say, right here, then we're just going to go down pretty quickly, probably even steeper than that. If we start, a little bit closer, we might hug this for a little bit longer, but we're still going to end up going down. If we start here, well, okay, then we're going to, looks like, go up, but eventually we have to get back to 0. So something like that. And if I started really close, then maybe, I could hug a little longer, but again, something like that. And then this one, it looks like we're just going to, wherever we start, we go down and then we hug 0. All right. And this is actually a very algebraically intensive one to solve that you can figure out later on. It's a separable equation. But there's actually two solutions here that are really easy. So there's one when y of x is 0, and there's another when y of x is 3. And you can actually see those as solutions. If y of x equals 0, well, that's the same thing as 0 times 3 minus 0 equals 0. So this is actually a valid solution to the ordinary difference equation. Y prime is 0 all the time, and y is 0 all the time, then it works. Another one is y of x is equal to 3. Because if you do that, you end up with 3 times 3 minus 3, well, that's 0. And y prime, 3 prime, is 0. So you end up with y prime equals this bit, 0 equals 0. These are actually solutions. And there's actually different solutions in each region. So that's nice. And if you actually drew it well, here's what it would end up looking like. Something like that. And so you get a somewhat good idea of what the solutions look like based on the slope field, even this poorly drawn one that I made. But right, this is a good job for computer. Again, I highly recommend the online tool that Ariel Barton made from the University of Arkansas. It'll draw the slope field for you, and then you can actually click on it to get the different integral curves.